Hello, everyone. Thanks for joining us for our next session of our weekly Wrangling RAG series, Agentic RAG. My name is Anna. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. And while we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional, and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenter to answer live. This session is being recorded. It will be available to view on demand within 24 to 48 hours. With that, I'd love to turn it over to our presenter. Thanks so much for joining us.
Hello. Hello, everyone in the chat who has said hi and good morning as well. So my name is Yujin Tang, and I am the founder of OSS for AI. OSS for AI is an organization that is aimed at getting all developers access to resources to understand, use, and contribute to the development and direction of AI. And we started with our first mini launch in December of last year, and we've been growing from 30 some people in January to over 4,500 people now. So as part of our efforts to do this stuff, we do things like this with the Microsoft Reactor. And so today we'll be talking about Agentic RAG. So let's get into the slides. So the first thing we'll start off with is just a review of RAG itself. And then we'll talk very briefly about AI agents, what they are, and what Agentic RAG is. And then we'll go into a workshop where I will walk you through some live code to actually build your own Agentic RAG example. So let me actually get that notebook sent to Anna. Okay, I'm going to put this in the... Here you go. Please put this in the comments. Okay, so if you have any questions during this time, please feel free to drop some questions below, and I will stop between at least stop between the slides and the code and try to answer any questions that come up, and then or since then, and then I will walk through the code, and you can feel free to drop questions as I walk through the code as well. So the first thing that we're going to talk about is just what is RAG, right? So RAG is a way to give your LLMs access to your data. So LLMs are these large language models that have been trained on tons and tons of data, and they probably not, I mean, some of them have been trained. For this example today, we're going to be using Wikipedia, so it's already been trained on Wikipedia data, but you'll see some nuances there. But for most production use cases, your LLM has not been trained on the data that you have, which is kind of what you want to do. So in RAG, you'll be using an LLM, which is the core engine that powers the RAG application. You'll be using a vector search engine, which is another name for a vector database. So vector databases are really search engines that sit on top of a permanent storage layer. The main core thing that vector databases do is the indexing in the compute. And then you'll have an embedding model. So embedding models are a way to turn unstructured data, such as images, audio, text, things like that, into vectors, vector embeddings, which is these long series of numbers. And then you'll have some sort of set of frameworks. So you might have evaluation frameworks, which we'll talk about, and like an orchestration framework, which we'll talk about as well. There might be other frameworks that you use, but for the purposes of this example, these are good enough. So this is the visual outline of kind of what a RAG application might look like. In the bottom layer, you'll see there's data that goes into an embedding model that goes into a vector database. And this is the basics of how you're going to load your data into a RAG application, right? So you take your data, and the embedding model is going to turn that data into some sort of vectors and store that into a vector database. And the top layer is how you actually use a RAG application, right? So there's going to be some querying, right? That's you, the user. You're going to be asking questions to the LLM, and the LLM is going to be taking those questions, embedding, those questions, and then sending those embeddings to the vector database and getting the top XK results, like top 3, top 5, whatever. It's going to get the results back, and then it's going to take those results, use them as context to answer the question, and return some sort of answer to you. So that's what RAG is. And then I've wrapped this entire thing in like an evaluation framework. So if you want to, when you put RAG apps into production, you're going to want to know what's going on. You're going to want to be able to trace your queries, trace your LLM calls, and then see how they do. And so you'll want to wrap them into an evaluation framework. So let's also just briefly cover some of the pieces of this tech stack, right? So we've got the LLM, and the LLM is something that has evolved from these like basic neural networks, right? If you go back to the 1970s, we have these like basic, we have these like deep neural networks that are like a few layers deep that are all fully connected. And then like as time has gone on, people have come up with different architectures for these neural networks. And one of those architectures was this recurrent neural network architecture that allows you to handle sequences, which is what was typically used for text for a very long time. And then in about 2018, these transformer models, which had an encoder and a decoder, came about. And what they did is they helped solve this problem of vanishing gradients, where you would lose context pretty quickly in RNNs. And then in 2022, GPT-3 came out, and it was this like massive improvement from the prior version. And GPT-3 uses this decoder-only architecture. And so what that does is it takes in these tokens that represent the input as well as the position and the context of where you are in your context, in your text, and it sends it to this decoder-only architecture, and it outputs some set of tokens that predicts what the next tokens will be given the previous tokens. And vector search is this way that we can compare unstructured data such as images, text, audio, video, etc. And we can compare these unstructured data in terms of numbers. So for example, here we have houses, puppy, dog, and cat in this top right. Is this left for you guys? Maybe this might be left for you guys. Top right corner for me. And what you can see here is that you can get like distances between these words using these vector representations. So you can see that puppy and dog are really close, and dog and cat are close, but not as close as puppy and dog. And then the furthest from all three of these is houses, which even though, puppies, dogs, and cats are going to be in your house, they're not as related to the house as they are to each other. So embedding models are just any deep neural networks that get you vector embeddings. Vector embeddings are derived from the second to last layer of a deep neural net. So in a neural network, when you pass information through, every layer, the network is going to learn, it's going to have a representation of that data. And at the end, what typically happens is you get an output that is what's it called? Prediction, a regression, or a classification. And if you cut that last layer off, what you get is you get the internal representation of all of the layers put together in that second to last layer. So the output of that second to last layer is taken as the vector. And that is a semantic representation of your data. That represents the meaning of your data according to that embedding model. So for this workshop, we're going to be using OpenAI for our LLMs. We're going to be using Face for vector search. I think we're just going to be using Hugging Face for embeddings. Embeddings, I typically like to use things from Hugging Face. We're going to be using LangChain for orchestration, and we're going to be using Arise Phoenix for our evaluation framework. So in our RAG architecture, this is something that you should have some familiarity with from the last slide. There's going to be the data that goes into an embedding model that goes into Face, and this whole like OpenAI Hugging Face triangle is kind of looped around with LangChain because we're using LangChain to orchestrate all of these different tools. And then outside, you'll see this little Phoenix here. This is Arise Phoenix. This is our eval stack, or this is our eval framework. So let's briefly talk about what AI agents are. I'm going to pause here just for any questions that might have come up from the RAG stuff. So if you have any questions about RAG, let me know, and I'll try to answer those before we get into the AI agent section. Okay. I don't see any questions getting typed into the chat here, so we're going to talk about AI agents. So the idea behind AI agents is actually quite simple. Basically, what we want to do is we want to allow AI to autonomously execute workflows, right? So if you're familiar with things like Zapier or IFTTT, like these kinds of things are workflows that can actually be executed by AI. You can give the AI some tools and tell it what the tools do. And the LLM will say, oh, well, I need to do this task. You also have to give it a task to do. I need to do this task. I have access to these tools. Here are the tools that I should do and how I should execute them in order to get this task to work, right? And that's basically the idea behind it. And this is also called like function calling. But the actual creating this kind of stuff is a little bit more complicated, um, mainly because LLMs operate in strange ways, and each LLM has a different interface in the way that it interacts. And so it's not going to be the same. You can't just use one LLM and give it the same set of tools and have it do the same thing as another LLM, which is where these frameworks like LangChain or the GPT interface or Llama Index or whatever, that's where these frameworks kind of come in to become important, is because they help you orchestrate all of these things on a larger scale. So a RAG agent is basically just us giving the agent these RAG tools and saying, hey, here's these tools, like you can call this vector database, you can do this, you have all this information stored in this vector database with this embedding model, and here's like what information it stores, and then saying, look for this information. And the LLM, instead of you setting the LLM up and to automatically query a vector database, the LLM will then say, okay, I'm looking for this information. I have access to this vector database. Let me get that information from the vector database and form some sort of answer out of it. So that's the basics of how an AI agent works and how an agent can do RAG. Are there any questions about agents? Okay, so someone has asked a question about Azure AI Studio. This talk is not about Azure AI Studio. I don't actually work on Azure AI. I don't even work at Microsoft. So unfortunately, I know nothing about PromptFlow or Azure AI Studio. But if you have questions about like the concepts themselves and not just the tools, you can feel free to ask some of those. I'll try to answer those. The tools that we're using in this example, we're going to be using LangChain with OpenAI to do some agentic RAG. I guess OpenAI is kind of a Microsoft company anyway. Agents, do they make their own decisions? Unlike, yes. So you don't need to tell the agent, like, hey, like you don't need to set up the workflow for the agent like you would in a regular RAG application. In an agent, you just give it a set of tools and it will decide which tool to use. So you'll see in this example, we're going to give it a RAG tool. And I think when we do the tracing, you should see that it calls the RAG tool. And you'll see that you're not calling the RAG tool. You're not saying, like, hey, use this vector store. You're just saying, this is a tool that's available to you. And the agent says, okay, I'm going to use this tool. Someone asks, what is the difference between an AI agent and a chatbot? So they're very different. AI agents are used to do multiple workflows. Now, in this example, we're building Agentic RAG, and RAG is basically a chatbot, with a few extra things on top of it. But AI agents execute multiple tools, they call multiple functions, and typically they're not even used to build RAG applications to chatbots. Agentic RAG is just a way that it's just like something that we've been using as an example to show how to build agents and how to build RAG together. How can we provide long-term memory to our RAG app? That's a good question. So you can, there's a few different options here. So one is you can use like a JSON memory store. Two is you can just store it directly into the vector database. And you probably want to store it into like a second instance of a vector database. So it won't be the exact same instance where all your context lives, but you'll probably want to store it into some second instance of a vector database. And the reason for doing this is because like if you want long-term memory, you're going to want somewhere to store it, and you're going to be able to want to access it. And you can use JSON, but then in order to query your long-term memory, you're going to need some sort of vectorization anyway. So you might just store it into a second vector database instance. Now, on the surface, in the interface, and the way that you interact with it, it may not interact as if you're interacting with a vector database. You may be able to use something that abstracts that away, so you're just working with some sort of memory. But in the end, when you're actually working with it, you're going to be doing some sort of vector database type work. Someone asks, what are the different vector databases and what is FACE? There's a bunch of different vector databases. I used to work at Zillis, so I used to use Milvus a lot. There's also like Weaviate, Pinecone, Quadrant, what have you, Elasticsearch, whatever. But basically, FACE is Facebook AI Similarity Search, and all of the vector databases are actually built on this algorithm. So yeah. Okay. I think I'm going to go ahead and share my screen for the code here. Okay. So I just ran this morning, and I'm just going to hope that it works again this time. So let's walk through some of these libraries. So the first library I've got here is LangChain. LangChain is our orchestration framework that we're using for this example. You can also build this on your own. You can use Llama Index. There's a bunch of different ways you can build this stuff. But LangChain is the one that we're going to use for this example. So we're going to use LangChain, and then we have LangChain Community, which is so a little backstory on LangChain. They created a ton of integrations back when they got started, and they found out that with the team of like just a few people, they couldn't maintain hundreds of integrations. And so they spun off the second library called LangChain Community, which is the community maintained integrations. And then there's also LangChain Hub. So LangChain Hub is just like a place where they store some prompts and things like that. Then there's LangChain OpenAI. This is how we access OpenAI. Then there's LangChain text splitters. This is how we split the text. You'll see this thing here, recursive text splitter, right? This is a way to split text. Now, there are many different types of text splitters, but recursive text splitter is a way that you can use to try to split on multiple different types of text. Uh-oh. An invalid Python interpreter is selected. Well, hopefully nothing breaks. Anyway, and then we have Face CPU. So this is the Facebook AI similarity search library, and we have it running using a CPU. I'm on a Mac, so I have quotes around this next one, but this next one is Arise Phoenix evals. So this is the Phoenix framework. Okay. Oh, there's a question. Someone asks, why does long-term memory need to be in a vector database? It doesn't need to be in a vector database. It's just that you're going to be doing vector search on top of your long-term memory anyway. So it's probably easiest to just have it in a vector database. Now you can put it into something like a JSON, but the long-termness of that is kind of doubtful because LLMs have limited context windows. And like you can give it a lot. You can so let's say you have 1,000 back and forths with an LLM, with your RAG app. Now what you're doing is you're making your calls to your LLM slower and slower as you increase your memory. And so what you want is you want a memory that is searchable, but doesn't require you to go and put a ton of context directly into your LLM, because not only is it going to be slow, but it's also going to be expensive, and it also compounds. Someone says, can we use chat history and feedback system with Agentic RAG? Yeah, probably. Yeah, I don't see why you couldn't use like a chat history mechanism. Once again, that is probably just an abstraction of how this works. But the idea behind putting your chat history into a vector database is that you should be able to search it. I'm not exactly sure what feedback system means, but you can probably use it. You can probably like give it you can give the RAG feedback like sorry, not plus minus, thumbs up, thumbs down, if that's what you're asking about. We're not going to build that in this example. Someone asks technical trade-offs between in-context prompt memory versus search and retrieve memory. In context, putting it into the prompt, the main pros there is that you can put whatever you want. That's about it. The cons of putting things into prompt directly is that you have to, if you're going to put whatever you want, you got to change it manually. If you put a lot of things, it's going to be slow. If you put a lot of things, it's going to be expensive. Mainly that. And then the pros of search and retrieve is that you can abstract away putting a lot of things into the LLM, so it's less expensive. It may be, it's usually faster up until a certain size, it'll be faster. And then because you're going to have to make an external call, but you probably won't be putting in like a ton of info into your LLM. The main con for search and retrieve is that you're going to have to you're kind of at the mercy of your LLM to search for the right thing, and you also need to maintain an extra tool to do stuff. Okay. Cool. Okay, there's no other questions. So we are going to walk through the code. So the first thing we're doing here is we're going to load this directory loader, and then we're going to get this recursive character text splitter that we looked at just earlier. So the directory loader basically helps you load in this directory of data. So you'll see that we have this a bunch of cities here. These cities are all scraped information from Wikipedia. That's what they are. And the recursive text splitter, like we saw earlier, is a way to split on certain characters. So let's import this. Okay. And now in this next section, all I'm doing here is importing Python or importing load.env and using it to set my OpenAI API key. This is because I'm using OpenAI as my LLM and I need the API key. Here we're going to launch Phoenix. So Phoenix is what we use to trace our calls so we can see what's going on behind the scenes. And at the end of this notebook, we'll stop and we'll click into Phoenix to see what's actually going on. This is just adding the LangChain part of Phoenix, so it knows we're using LangChain. And now we're going to split up the text. So we're going to use our recursive character text splitter, and we're going to create one that splits on chunk size of 1024 with a chunk overlap of 128. So chunk size and chunk overlap just refer to the size of your chunk document and how much it overlaps between every other chunk document. If you want more information on this, you can check out my LinkedIn course, which is going to be coming out in October. So yeah, and then the directory loader, what we're going to do here is we're going to load the directory. Basically, we're going to get the data, and then we're going to call this loader here. So you can do this manually, or you can just load and split. So if you want to have metadata and you want to customize your metadata, you'll probably want to do this manually. But if you just have the directory loaded, you can call load and split and pass in the text splitter. And what it will do is it will load up all the files and it will run the text splitter on those files without you having to do much on this. Now, the pros of this is that it's very simple, it's very easy. The cons of this is it's less customizable. So if you want to customize this yourself, you're probably going to want to loop through each file and create documents with customized metadata on it. Okay, so in this next block, what we're doing here is we're importing Face and the OpenAI embeddings. Yes, so I didn't use Hugging Face for this one. You can use OpenAI embeddings, you can use Hugging Face embeddings, it really doesn't matter. I mean, it matters for production level stuff because it'll, like, they're different sizes and they're also different, they're different sizes and and you can only compare vectors the same size. But for this basic example, it doesn't really matter which embedding model you use. So then after we get our embeddings, we're going to create our vector store. And all we're going to do is we're going to use Face. We're going to pass it these documents that we created earlier that we split and loaded. And then we're going to give it the embeddings function. Okay. Now we're going to turn that the vector store, the vector database, into a retriever object. So typically when you work with a vector database, you need to pass in vectors in order to get vectors back. But the retriever object, what this does is this says, hey, you have this vector database, you have these embeddings. We're not going to make you pass in these vector embeddings. You can pass in a string prompt. Not a string prompt, just a string. And we'll do the embedding for you. And you can just treat this as if it's a retriever. So now this is where the agentic part of RAG comes in, right? So now we have the vector store ready. And now we're going to turn this into some sort of agentic type model. So what we'll do here is we'll create a tool. And we'll just create a retriever tool, which takes a retriever. And then we're going to name it search cities. And we're going to say that it searches and returns excerpts from Wikipedia entries of many cities. Okay. And now we're going to create this list of tools. So you'll see this used later. This is not terribly important right now, but typically when you create an agent, you give it a list of tools. In this case, we only have one tool to give it, but we need to put it into a list because it expects a list object. Now what we're going to do is we're going to use LangChain Hub. We're going to pull this OpenAI tools agent prompt from Harrison's hub. So the first thing we're doing here is we're getting a system message prompt, which has a prompt template. And basically the template says, you are a helpful assistant. Basically, that's all we need to tell the LLM. And someone mentioned chat history. So there is a chat history here. So you can put the chat history into the prompts. And then there's also this human prompt template, which basically just takes the input. And there's a way for the agent to use the output as a scratch pad. And now we're going to get the, we're going to use chat OpenAI. So this is just the chat interface for OpenAI. And we're just going to set a temperature of 0. We don't want it to be creative. We want it to follow instructions, basically. And then we're going to import the agent executor, and we're going to create the tools. So the first thing we're going to do here is we're going to create these tools agents. So what this does is this creates an agent object that uses a certain LLM that has access to a certain set of tools and is given a certain prompt. So these are the 3 things that you need to create the agent object, okay? And now what we're going to do after that is we're going to create this agent executor, which is an executor for the agent object that can use those tools. And we're going to say, here's the tools that your agent can use. This is something that you have to pass in. This is kind of a little bit redundant, but it's also, doubly effective to ensure that if the tools change, you can change the agent executor's tools. Oh, I ran that twice. Whoops. Okay, so we did this bunch of cities, and now we're going to ask, who is Taylor Swift? And so last time it says, I apologize for the inconvenience. It appears there's no relevant results for Taylor Swift in the Wikipedia entries of cities, which I hope it does again this time. And it did. So here you can see that the agent does not look for Taylor, or does not find Taylor Swift in the cities, and says, okay, out of all the tools that I have no information about Taylor Swift, so I'm not going to give you any information about Taylor Swift. But if we change this and we say, compare and contrast nightlife in Boston and Cairo, it should be able to do that. I've never been to Cairo, by the way. If any of you have been to Cairo, maybe you'll have some more insight onto this, but I have no insight onto this, so I should not have asked this question. Boston has several theaters, blah, 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 blah. Major annual events include first night on New Year's Eve, blah, 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 blah. A lot of stuff about Boston. Let's hope that we also get some stuff about Cairo here. Boston, Boston, Boston. Cairo. Cairo is known for its diverse food scene, including Arab cuisine, Middle Eastern cuisine, and local staples like koshery. Oh, I don't even know what koshery is. Exclusive restaurants in Cairo, blah, blah, blah. Inference from the modern Western society, blah, blah, blah. Oh, McDonald's. Damn, McDonald's in Cairo. Okay. Cool. And then maybe we can also do which city is better for historical, or which city has the oldest historical landmarks out of Paris, Seattle, and Houston. So hopefully this one says Paris. At least I think that's true. Seattle and Houston have not been around for that long compared to Paris. Paris, yes, exactly, has the oldest historical landmarks out of the 3 cities mentioned. Paris has a rich history dating back to ancient times, with many historical monuments and buildings that have been preserved over the centuries. Some of the iconic landmarks in Paris include the Eiffel Tower, the Notre Dame Cathedral, the Louvre, and the Palace of Versailles. I've been to all of these places. These landmarks show the city's long and storied history, making Paris a treasure trove of historical sites. We'll do one more. And by the way, you can be thinking of questions to ask, and we'll ask some questions to the agent as well. And in a few minutes after we ask these questions, we're going to go look at the traces. But I'm going to ask a couple more questions, and then I'll see if there's any questions from the audience that we can take for the agent as well. Let's see. What languages would I need to speak to tour Lisbon, Munich, oops, and Tokyo. So it probably just says English because I think all these cities speak English, but maybe it'll also give me Portuguese, German, and Japanese. Portuguese, German, Japanese. So there you go. The agent, it's pretty good. It's basically all we did was give it this tool of cities, and we're gonna see later like what it searches and how it runs through these cities. Yeah, let's see if there's any questions. Oh, whoa, there's a lot of questions that I missed. Let's see. Should I do semantic chunking or recursive chunking? That's up to you. That's an implementation thing. Semantic chunking is, I mean, they're both kind of time consuming. Recursive chunking is a little bit faster, I guess. And semantic chunking is a little bit more costly, but could lead to better results. So, what I would do is I would just test both and see which one you like more. How much do embeddings cost? They're free if you use Hugging Face or if you run them locally. Now, I use OpenAI, and I have $100 in OpenAI credits that I just charged my account with recently. So less than $100. I don't know. It's the pricing page is on OpenAI. Face loads data in memory and is not suitable for large data. Replace it like with a vector database. What do you think Milvus Pinecone do with their data? They load it in memory too. That's how vector data works. Now, the advantage of using Milvus or Pinecone is that it doesn't load into. I mean, Pinecone is an API; it doesn't load it into your memory, so that's nice. Milvus has a distributed system that is automatically distributed. So I used to work on Milvus, by the way. So Milvus is distributed, and so it has automatic distribution, distributed system for if you have really large amounts of data, and you'll start to see differences around 10 million vectors. So if you're working with real true enterprise scale usage that has 10 million vectors that don't need to be logically separated from each other, which is actually still pretty rare use case, then yes, go with Milvus. Okay, everyone else has sound. I see that it's taking 4, 6, and 7 seconds to retrieve the results. How can we speed it up? It's not taking that long to retrieve the results. It's taking that long for the LLM to execute. This is just the price you pay for using an LLM. It takes time, and that's because LLMs are big and there are billions of parameters. They take a long time to run. You can make it feel faster if you can load different pieces, like if you can stream the data from the LLM, which is exactly what ChatGPT does on the website. By the way, it streams the data in. Yeah, I mean, unfortunately, this is just the nature of using LLMs at the moment. Now, in the future, there will be probably faster LLMs and stuff like that. And actually, here's something that's interesting for you. So one of the slowest things about using LLMs is this thing called matrix multiplication. And if you check out my YouTube channel, I did an interview with someone to talk about matrix multiplication free LLMs. So you can actually have LLMs that are much faster and much lighter by getting rid of the matrix multiplication, and you lose a little bit of your, I don't know, powerfulness of the LLM by doing this, but it does make it faster. Can we use open source? Yeah, you can use whatever LLM and vector database you want. Pricing is usually okay. So someone, okay, thank you for answering that question, Trebity. Anyway, yeah. So does anybody have any questions they want to ask the RAG agent before we move on to look at what the actual calls were internally inside of the application? I'll do one more. Let's see. Which city is the biggest out of London, Karachi, Houston, Copenhagen, and this one's actually wait. Which city has the best food scene? So this one actually, last time I did this, it surprised me. I don't know what it's going to say this time, but how do I? Okay. I shouldn't have set this as a result. I should have set this as an interactive manner. Okay. So this one, this is a setup issue. If you set it up to be one off like I've set it up, you're going to run into some of these issues. So let's do these cities: Moscow and Paris. All right. Brief overviews of the food scenes. Does it actually tell us which one has the best food scene? Let's see. The best food scene would depend on personal preference and the type of culinary experience one is seeking. All right, so ChatGPT is, clearly guardrailed to not take a very strong opinion on this, but I don't have an opinion on which one of these has the best food scene either. They just tell you what's in the different ones. This is a really long example, so I'm not going to read all this. So I think now what we can do is we can go take a look at the tracing. We can go look at all of the different calls that were made. Great. So you'll see here we have a bunch of different calls, and some of these took longer than others, up to 1 second, 7 seconds, 8 seconds, blah blah blah. So let's take a look at this first one here. Who is Taylor Swift? So we asked who Taylor Swift is, and it says, okay, I got it. Here's the tools I can use, and I want to look for Taylor Swift. I'm invoking search cities, looking for Taylor Swift. And none of these cities has anything about Taylor Swift. Right? So you can see that it's trying to call these tools using search cities, and there's no Taylor Swift. Although it does match Taylor Swift's music. But you can see that none of these information has any information about Taylor Swift. So it says, I can't tell you about Taylor Swift. Now, clearly, GPT-3 knows about Taylor Swift, but because it's not in the data, this time this agent was very good and it did not return anything about Taylor Swift. So what happened when we called this? It says, okay, here's the cities, here's the tools we can use. We can see 2 search cities tools, and that tells us that very likely what happened here is, here we go. We got to search nightlife in Boston and nightlife in Cairo. And so what it does is it calls the search cities and it gets the nightlife in Boston. Here's that. Nightlife in Cairo. Here's that. And then a lot of documents about it. And then in the end, we give all of this information to Chat OpenAI, and it does the comparison, and it tells us about the comparison. Boston offers a diverse range of cultural events, theaters, and historic sites. Cairo's nightlife is characterized by its food scene. So you can see that if you were to do this with one vector DB and just use your own vector DB, you would have to tell it to search the Boston DB and then the Cairo DB. But with the agent, it's able to tell a difference and search both. And so here we should see that it searches many cities, right? So this one is going to be Paris, Seattle, and Houston, right? And then you should see that again. Geez, clicking all over the place. So this one, it says, which city has the best food scene? It says, I don't know. But, I can search outside of these because you have to specify some cities to search for. Would I need to visit these cities? And it should say, here we go. Languages spoken in Lisbon, languages spoken in Munich, languages spoken in Tokyo. And then you can see all these different retrievers and the final prompt and how it is. Okay. And then we give it all these cities and it should search all these different cities, right? Lisbon, Houston, Berlin, Moscow, Paris. Okay. So yeah, that's basically how this works. And I think these are the basics of how you can build an agentic RAG app, what a very simple toy example looks like, and what's actually going on behind the scenes. I'm going to stop sharing the screen now. I'm going to put up some of my own slides and just let them loop while we wait like a couple minutes to see if there's any questions. So these slides will loop through for jobs in AI, how you can find me, and other, what do you call it? Other tech events, tech talks in the Seattle and SF area, as well as online. So I'm going to, oh, can you turn your, yes. I'm going to be just, oh, I'm in the stream with audio only. I didn't even know I could do this. Okay. Anyway, I'm gonna let this loop for a little bit, and then if you have any questions, we'll take questions for the next few minutes, and I'll try to answer all of your questions while this loops. What IDE do you use? I use VS Code, and I use VS Code with high contrast dark theme, I believe is what it is. If that's, let me see. Let me see what I use. Themes. Where is it? Eh? I have no idea. Oh, appearance. Here we go. No. Editor, Explorer, testing, extensions, terminal, debug console. I'm pretty sure it's high contrast dark mode is my theme that I'm using with VS Code. And oh yeah, VS Code is a Microsoft product. I totally forgot about that. And it is honestly the best IDE, like straight up. It's better than anything JetBrains has ever produced, or probably will ever produce. That's my personal opinion. Yeah. Regarding response time, can we do the embedding and vector database creation early and not at runtime either? So if we pre-train the LLM. So I think that's a misconception here. You can't pre-train an LLM. And in fact, in the example, we did do the vector database and embedding early. So we embedded our documents and put them in the vector database before we did anything with the querying. And for production use cases, like when you're building RAG apps and stuff like that, you should 100% have your embeddings in vector database created before you put it into production, right? I mean, just like any other software tool, just like any other app, you want to have your database ready in production and all of that stuff before you release it to users to try. And then in terms of like pre-training the LLMs, like the LLMs are pre-trained, right? GPT stands for Generative Pre-trained Transformer. So will it improve performance? It probably won't. You can fine-tune an LLM if you are thinking about fine-tuning LLMs, but fine-tuning LLMs doesn't work well for factual responses and factual tuning. Fine-tuning LLMs is mainly for style. So for example, if you want the LLMs to always output in JSON, or if you want the LLMs to do function calling, that's where fine-tuning is helpful. Can we create a data pipeline for embeddings into the vector database? And will that be used in the LLM in prod in real time? Um, you can. And here's where I'm going to refer you to my YouTube channel again. So I just did an interview with Xander Matheson from Bytewax, Bytewax. And what they do is they do real-time data streaming they do real-time data streaming. And you can 100% check out that talk. It's on my channel. And I'll link these talks that I've been talking about, so you can see these talks instead of me just telling you to go to my channel. So first, this is matrix multiplication free LLMs, and this is the real-time data streaming one. Real-time data streaming. What methods do you typically use to test the performance of embedding models and determine the appropriate chunking size? Honestly, I use the evals, right? So you use like Arise Phoenix and you just evaluate your results, and you can use something called LLM as a judge. So I didn't show it in this example, but I did show in the last two examples, or in two examples ago, sorry, where you can use like GPT-4 as a judge of how well your RAG app is performing. So yeah, you use a framework like Arise Phoenix to do that. Okay, if there's no other questions, I think I'm happy to wrap the session here. Yeah, we got 7 minutes here. Yeah. Oh, some people say that long context LLMs like Gemini would turn RAG obsolete. What do you think? So I think we've already covered this a couple times in here, but the main thing is just like it's gonna. Are you gonna put 1,000,000 pages into Gemini? I mean, you can. Is it gonna be effective for you? Probably not. It's gonna be like it's gonna be both cost and time ineffective. So I don't think that's gonna happen. At least not for a while. You know. Thoughts on lane graph? How's it different with agents? I haven't used lane graph, so I don't know. Cool. Looks good.
Thanks, everybody. Thanks, you, Jen, for another awesome session. We are always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find the link on the screen or in the chat. Today's event code is 22961. We'll see you at the next one.